dear students, welcome to e-Prashnik Badaledi program. Today we are going to learn about how to write a formula for a given chemical compound. Chemical compounds are of two types. One is stoichiometric compounds, another is non-stoichiometric compounds. Stoichiometric compounds means which follows valency rules. Valency means it's a combining capacity of the atom in a molecule. Carbon has 4 valency, hydrogen has 1 valency. To saturate, to bond tetravalence of carbon, 4 hydrogen atom, univalent hydrogen atoms are required. So its formula is CH4. Similarly, another example, if you take sulfur has 2 valency, bivalent sulfur can form bonds with 2 hydrogen atoms, so that it gives H2S formula of a compound hydrogen sulfide. Similarly, other examples if you see, non-CaCl4, P2O5 like that. The other compounds are non-stoichiometric compounds. Non-stoichiometric compounds means they do not follow normal valency rules of elements. They do not obey the valency rules. For example, Fe3O4 you see. Fe has 2 valency or 3 valency. Ferrous, ferric. Fe has 2, that is ferrous. Fe has 3 valency, that is ferric. But here it has so much odd number of valencies there. This is called ferroso-ferric oxide. It is neither Fe2O3 nor FeO. It is a combination. It seems a combination of Fe2O3 and FeO. So this type of formula is do not following the valency rules of Fe and oxygen. So it is a good example for a non-stoichiometric compound. So transition metal hydrides and borides, carbides, nitrates also do not follow the valency rules. So they are also examples for non-stoichiometric compounds. Here, how to write a chemical formula for stoichiometric compounds. Mainly, the crisscross method is used to write a formula for a compound. In this, so many rules are there. See, every formula of chemical compound contains 2 parts. One is a cationic part, another is anionic part. Cationic part means positive part, anionic part is negative part. Or in other words, you can say less electronegative atom and more electronegative atom. More electronegative atom, 2 parts will be there. First part, less electronegative atom or cation is written on the left, and anion is written on the right. Positive part, electropositive or less electronegative ion or atom is written on the left. More electronegative ion or radical or anion is written on the right. Afterwards, what you have to do, charge numbers of one radical, one part is written under other radical, other part as a subscript, at the bottom of the other part. Similarly, the charges on the other part number will be written at the bottom of the first part, that is cationic part. In this way, if the subscript numbers of radicals are simplified, they should be simplified and write in the form of a formula. If the subscript is 1, that need not be written. After simplification, if an atom, if cation or anion gets 1 number, that need not be written. These are some rules. Let us see the examples. So, ammonium sulfate. Ammonium sulfate. What is the formula of ammonium sulfate? Ammonium is a cation, positive ion. So, right, left, right 4 plus. Anion, sulfate. Sulfate anion, it has 2 minus. So, you leave this plus and minus. The numbers are simply gives the valency rules. Valency. According to valency rules, the positive charge, if you oxidation, the positive charge is, if you neglect the positive charge, only the number you take, that is valency. Here 2 valency. Then afterwards, what you have to do? The crisscrossing. The 2 valency 2 is written at the bottom of the NH4 plus as a subscript. And sulfate ion, under sulfate, you have to write the valency of NH4 plus at the bottom. So NH4 twice, NH4 twice, SO4 1. 1 need not be written. So NH4 twice sulfate, SO4 is the formula of ammonium sulfate. NH4 twice, SO4. SO4 of 1 you have to write, but the 1 can be neglected. So you need not write. NH4 twice, SO4. SO4 is the negative ion. But while writing this one, you need not write the charges. Only the charges should be known to write whether it is written in the left or right sides, and it also gives the number, it also gives the in the form of valencies. So for example, valency is a group number. G means group number of the element if less than 4. Fourth group, if the element belongs to less than 4 or 4, then its valency can be considered as its group number. If it is more than 4, group number is 4, greater than 4, that's the fifth group element, then the valency is taken the group number minus 8. That means fifth group, 5 minus 8, minus 3. So more than group number is greater than 4, the valency is that group number minus 8 is considered as a valency. So for example, you take element X and Y are taken. Electronic configuration, EC means electron configuration. Its electron configuration 1s2, 2s2, 2p6, 8, 3s2, 3p6 and 4s2. 4s2 is the last valency shell electrons. It is 2, it belongs to second group. So its valence is 2. It has 2 plus, you can write 2. Its valence is 7 electrons are there, but it is more than 7. The valence electrons are more than 4. So if it is more than 4, the valence becomes 7 minus 8, minus 1. Minus 1, minus is to write right side, 1 is the valency. Afterwards, what you have to do? Crisscrossing. The valency of Y is written under the X. The valency of X is written under the Y. So you will get X1, Y2. 1 need not be written. So XY2. XY2 is the formula for this element. X, Y2 is the formula of this compound. For example, metal, it has 3 plus, phosphide, it has 3 minus. It is a third group element, 3 plus, it is phosphide, fifth group element, 3 minus, 5 minus 8, 3 minus. So you should know, you should remember these charges. After leaving the charges, the numbers will be the valency, 3. It has also 3 valency. After crisscrossing, these 3 is written M3 and P3, M3 and P3. But 3:3, the atoms ratio is 3:3. It can be simplified, 1:1. So M1, P1. You need not write the ones. So MP is the formula for the metal phosphide. You see how to know the valencies from the periodic table of elements. For example, first group elements, the oxidation state is +1, valence is 1. Hydrogen, lithium, sodium, potassium, rubidium, cesium, France, all these elements have +1. Second group elements, one NH2 configuration, beryllium, magnesium, calcium, strontium, barium, these are all +2 configuration, +2 oxidation state. Leave the transition elements because they exhibit several valencies, multiple valencies, variable valencies. So third group boron, aluminum, these exhibit third group elements, so +3. Fourth group element, carbon, C plus, silicon plus 4 plus, C4 plus, silicon 4 plus. And fifth group elements, nitrogen, phosphorus, these are fifth group. Because it is greater than 4, so its oxidation state or its valence will be group number 5th minus 8, 5 minus 8, this is -3. So nitrogen, anhydride ion, phosphide ion, arsenide, like that. These are metals. Metal always exhibit +3 oxidation state. Afterwards you can see. Oxide, oxygen, the sixth group elements. Sixth group elements has valency 6 minus 8 because it is greater than 4. Oxide, sulfide -2. Seventh group elements. 7 electrons are there in the outermost shell. That means 7 is greater than 4. Since it is greater than 4, it is 7 minus 8 will be the valency. -1. Valency is 1. For zero group elements, that is inert gases, they cannot form bonds. Their valency is 0. Valency is considered as 0. So it is a list. So you have to remember the first group elements +1. In addition to that, silver plus. Second group elements are +2 Mg, calcium, magnesium, calcium, strontium, barium, like that, +2. In addition to that, transition elements, some transition elements mostly they are come in various compounds, various in the form of formulas. Zn 2+, Cd 2+, aluminum is 3+, bismuth is 3+, bismuth is 3+, and carbon is 4+, silicon is 4+. Ammonium cation, polyatomic cation, ammonium NH4+, 1+, but NH4, 4 multiple atoms. These are all single atoms. It is a polyatomic cation. H3 plus hydronium ion. Anions, you see, hydride ion. H plus is the cation, H minus is called hydride. Fluoride, seventh group elements. Fluoride, chloride, bromide, iodide. These are all seventh group elements. Seventh group elements has -1 oxidation state. These sixth group elements, oxide, sulfide, 2 minus, sixth group, so 6 minus 8, 2 minus, you have to remember. Fifth group elements, nitride, phosphide, M3 minus, nitride, phosphide, like that. Carbide, fourth group. Sometimes you will see 4 minus also, 4 plus, it also exhibits 4 plus and 4 minus also. Polyatomic, multiple atomic anions are OH minus hydroxide ion, cyanide ion, peroxide ion, oxide ion, O2 minus, you see O2 minus, carbonate, CO3 2 minus, oxalate, C2O4 2 minus, and nitrate, NO3 minus, phosphate, PO4 3 minus. You have to see, you have to remember most of the ions so that you can write correct formulas. Bicarbonate ion, bisulfate ion, so many ions are there. Nitrate ion, phosphate ion, sulfate ion, like that. So sulfate ion, they have charges. You have to remember the charges. Then only you can write the correct formulas. So this is the list of anions and cations. While writing the formulas, you have to put those ions of a particular concerned compound. So let us see. Ammonium sulfate, you have already seen. Ammonium ion, 1 valency, sulfate, 2 valency. This 2 is written under the ammonium. This 1 is written under sulfate. So ammonium sulfate is the formula of NH4 SO4 is this formula of ammonium sulfate. So metal oxide. So here metal oxide is the M oxide is O2 minus, you know already in the list I have seen. So M should have 2 plus, then only it will be neutral. Metal has 2 plus. You have to find out the formula of this metal nitride. This is the answer. How it came, let us see. M has 2 plus from this formula. M has 2 plus. Nitride already in the list, N3 minus, nitrogen has T minus, then only nitride ion. It's fifth group element, 5 minus 8, 3, minus 3. So it is written in the right, it is written on the left. So the valence of 2 is, this valence is 3. Simply leaving the charges, it can be considered as a valency. So these kept here M3, M3, N2, M3, N2. M3, N2 is the answer for the metal nitride of particular compound having valency 2. Metal ion having valency 2. Here pyrophosphoric acid. Pyrophosphoric acid is H4P2O7. Each H is a plus 1. 4 hydrogen atoms are there. 4 plus 1. 4 plus. So pyrophosphate ion, you will get 4 minus. Then only 4 hydrogen atoms are bonded with that pyrophosphate ion. So from this formula, what you understand, that is pyrophosphate ion has 4 minus. So that 4 minus ion I have kept here. Magnesium. He asked the formula of magnesium pyrophosphate. Magnesium is the second group element, Mg2 plus. The valence is 2. Its valence is 4 minus, so 4. 4 is kept here. Mg4. P2O4, P2O7 2 twice. P2O7 twice. But it is a 4:2 ratio. This ion and this ion ratio is a 4:2. So that can be written as 2:1. So Mg2 P2O7 of 1. So 1 can be need not be written. So Mg2 P2O7 is the formula of magnesium pyrophosphate. If the formula of potassium ferrocyanide K4FeCN6 is this one, from this what ion? K is an alkali metal, K plus 4 Ks are there, 4 plus are there, so this ion should have 4 minus. 4 minus. Ferrocyanide ion has 4 minus. That 4 minus is kept here. He asked the formula of ferric ferrocyanide. Ferric iron has 2 oxidation states, Fe2 plus and Fe3 plus. Ferric is Fe3, ferrous is Fe2. He asked ferric ferrocyanide, so ferric is Fe3 plus. Ferrocyanide ion is 4 minus. From this formula I got this. The valence is 4, this valence is 3. Crisscrossing, 4 is written as here, 3 is written under this ion, this complex ion. Fe4, FeCN6 3 minus is called ferric ferrocyanide, is called a brown ring, you can say. Ferric ferrocyanide. Formula is this, Fe4, FeCN6 twice. These are coming in the EAP set like that. Let us see some more formulas. Copper ferrocyanide. Already we have seen ferrocyanide ion is FeCN6 4 minus. Cupric. Copper also is a D black element, transition element. It cuprous and cupric. Cu plus 1 plus is there called cuprous. 2 plus is called Cu2 plus is called cupric. He asked cupric, so Cu2 plus. Ferrocyanide ion 4 minus. That means this valence is 4. The valence is 2. It is written under this ion. This 4 is written under this ion. Cu4 FeCN6 twice. But these ions ratio 4:2. It can be simplified. So 2:1. One need not be written. So Cu2 FeCN6 is the Cu2 FeCN6 is the formula for cupric ferrocyanide. Formula of aluminium phosphate. Aluminium is third group element. So aluminum has 3 plus. Phosphate ion is 3 minus. Phosphate ion, phosphoric acid H3PO4, 3H plus. So 3 plus or 3 minus. Phosphate ion has 3 minus. The valencies are 3. Valence is 3 because you simply crisscross. Applying crisscross method. Al3 and PO4 thrice 3. Because these ions are 3:3. So it can be simplified 1:1. Al1, PO4 1 or Al, PO4. Aluminum phosphate is the formula, has formula Al, PO4. Formula of ferric dichromate. Similarly, dichromate ion is the chromic acid, dichromic acid, Cr2O7 2 minus. Valence is 2. Ferric means Fe3 plus, so valence is 3. On crisscrossing, 3 is kept here under this ion, 2 is kept under this iron atom. Fe2 Cr2O7 thrice. Fe2 Cr2O7 thrice. This is 2:3. It cannot be simplified. So this ion's formula is ferric dichromate formula is Fe2 Cr2O7 thrice. Let us see. He is simply given the atomic numbers. So you can write the formula also. 20 and 7. X has 20, Y has 17. 20 means 1:2, 2:2, 2p6, 2s2 2p6 is 8, 3s2 3p6 is 8, 4s2. Outer shell, valence shell contains 2 electrons, so it is a second group element, its valence is 2. For this 17, 1s2, 2s2 2p6, 8, 1s2 2, 2s2 2p6, 8, 3s2 3p5, 7, but it is a more than 4, so 7 minus 8 will be the valency. Its valence is 1. 7 minus 8 is equal to minus 1. You leave minus, so 1 is the valency. On crisscrossing, x1, y2, x1, y2, that is xy2. xy2 is the answer. Atomic numbers of x and t are 30 and 15 respectively. Then their normal compound formula is x is, this is t, x 30. 30 means 1s2, 2s2, 2p6, 1s2, 2, 2s2, 2p6, 8, 3s2, 3p6, 3d10, 18, 4s2. Outer shell is, fourth shell is the outer shell, valence shell. It has 2 electrons. So it's a second group element, 2. Valence is 2. Not less than 4, so it's a 2. Here you see y. Y is the 1s2, 2s2, 2p, 6, 1s2, 2, 2s2, 2p6, 8, 3s2, 3p3. Total 5 electrons are there. 3s2, 3p, s2, p3, 5 electrons. But it is more than 4, so 5 minus 8. 5 minus 8 means minus 3. Minus 3 means after leaving the minus 3. Its valence is 3. Its valence is 3. Y has 3, x has 2. On crisscrossing, y or t, you can think t. x3, y2 or t2, x3, t2. x3, t2 is the formula for that compound, having atomic numbers 30 and 15. Let us see, phosphide. Trivalent metal. Trivalent metal, valence of metal is tri. Tri means wood, 3. Trivalent. Phosphide. Phosphide valence is 3. P3 minus 3 is the valency. 3 plus 3 is the valency. Or crisscrossing, M3, P3. M3, P3. Simplification, MP. M1, P1 or MP you can write. You see, outermost shells of 2 elements X and Y have 2 and 6 electrons. Outer X has 2 electrons in the outer shell. It is less than 4, so 2. 2 is the valence of X. Y has 6. 6 means more than 4. So 6 minus 8. That also has 2. X minus 2. Minus 2 means you leave with minus. Y has also valency 2. X has also valency 2. X2, Y valency is written in X. X2, Y2, Y2, X2, Y2. X2, Y2 is the formula, but it can be simplified. So XY is the correct formula. A is the correct one. It is written like this here. XY is the correct formula for this. 2 electrons and 6 electrons are there in the valence shell, outer shell. If it is less than 4, its valence is 2. It is more than 4, 6 is more than 4, so you have to take the difference, 8, between 6 and 8, the 2 is the valency of Y. On crisscrossing, X2, Y2, on simplification, it will be XY. XY is the valency. Compounds which elements do not obey valency rules are called, if it obeys the valency rules, that is called stoichiometric compounds. If you do not obey, those are called non-stoichiometric. If you do not obey valency rules, so this is called non-stoichiometric compounds. You see, in this which is non-stoichiometric, these are all following the rules. Fe3O4 is the not following the valency rules, so it's a non-stoichiometric compound. Here, correct formula of the trivalent metal nitride. Metal nitride, trivalent means metal has a 3 valency, nitride has 3 valency, M3 and N3 crisscrossing. N valence 3 is written here, M valence 3 is written here, M3, N3. But 3:3 is the ratio is can be simplified. So Mn is the correct formula. This is not correct formula. This is C is the correct formula for this. Valency of sulfur is sulfuric acid, H2SO4 is 6. Later, you can know the writing the oxidation state or learning the oxidation states, you can know the valency of sulfur is 6. Valence of inert gases. Inert gases, zero group elements, helium, neon, argon, krypton, xenon, radon. These are all zero group elements. They do not lose or gain electrons, so their valence is considered as 0. Thank you. Like, share and subscribe.